Was me.
Okay, thank you and welcome to this session. This session is definitely hybrid because we have some of our speakers are online and participants are online. So when you ask questions, make sure that you use there's a microphone here and a microphone there and somebody willing to run a microphone around. So just make sure you use the microphone. So in addition to the welcome, I wanted to remind everybody that this meeting is taking place using the RDA Code of Conduct and the RDA guiding principles of openness, consensus, inclusivity, harmonization, community-driven, nonprofit, and technology neutral. And if you haven't already done so, the housekeeping is for both people in person and online. The collaborative notes, there's a link to them. If you're remote, if you go to the page that describes the session, there's a link to the collaborative notes there. And so please use the attendee check-in, and we'll have a little bit of time for questions after each talk, but then we have a larger discussion time. So if you have a question about a particular presentation, you can ask a couple then, but let's try and save most of them for the discussion. And when you are talking on either remotely or for people presenting for people who are attending remotely, you can put your questions into chat. And we have somebody in the room that is monitoring chat, and we will make sure that we also address your questions. Okay, so I am one of three co-chairs. My name is Rebecca Koskela from RDA US. The other two co-chairs, Alex Ball and Keith Jeffrey, are both attending this session remotely. And the other thing I wanted to give you just a little background in case you haven't been to a metadata interest group meeting before. So if you're in the room, actually, if you're online, could you put in chat whether you, how many plenaries you've been to for RDA? And I'll do this hands up for in here. For the people in the room, is this your first plenary? Oh, wonderful. Okay, how many have been to between 2 and 5 plenaries? How many people have been to more than 5? There's a few old timers with me. Okay, thank you. Okay, and one other question is, are you a member of the metadata interest group? If you're in the room, raise your hand if you're a member of the metadata interest group. Great, and I will, the collaborative notes tell you how to join. If you'd like to join after this, it's very easy. Okay, so a little bit of background. The metadata interest group is actually one of the very first RDA interest groups, and it was formed in 2013. It has spun off 2 very successful working groups. The first was the Metadata Standards Directory Working Group. This is a human readable directory, and what it was meant to do, the digital curation has a very nice metadata standards directory. And what this allows people to do is if they see a metadata standard that's missing or an example, a use example that's missing, it can be updated, and then it keeps the digital curation metadata standard directory current and up to date. The second group that was spun off is the Metadata Standards Catalog Working Group. And the difference from this is the catalog is machine readable. And I've got the link in the slide to be able to go to the machine readable metadata standard catalog, and our group page on the RDA website also has a link to the metadata standards catalog. And what the main point that the metadata interest group is working on right now are the metadata element set. And there's a link to that also on the working on the interest group page. Okay, so the agenda is this. We'll have the meeting objectives. Alex will do that. And then Keith will actually talk about the metadata elements. And then John Grable will talk about metadata and vocabulary services. He's in the room. The next one is Andrea. It'll be a remote presentation about the metadata that's effective for scientific knowledge graphs. And another one from in the room, Reiner will do the metadata required for fair digital objects. And then we'll have 30 minutes for discussion. And I'll also introduce two new co-chairs, and we have room for more additional co-chairs if you're interested. So let me know after the meeting if you're interested in becoming a co-chair, because we'd like to have, ideally within RDA, you want to cover the different continents, and we will have US and Europe, but it would be great to have somebody from Oceania or Asia or Latin America as a co-chair. And then we'll talk about next steps. Okay, so Alex, are you ready?
I am indeed. So
let me know when to advance your slides.
Okay, well, let's crack on with the first one then. When I first qualified as a librarian, one of the hot topics of the day was, has full text indexing by the likes of Google made cataloging resources an obsolete practice? The answer turned out to be no, because while machines can infer a lot from full text, it's so much easier to build services on solid facts. So if we go to the next slide, please. That's why we've marked up our web resources with schema.org, why we've built persistent identifier systems with metadata kernels and expended effort populating graphs of linked open data. That's why we value machine actionable metadata over merely machine readable metadata, and machine readable metadata over just simple free text. Coming on to the next slide. Now we're coming into an age being shaped by machine learning and AI, and the same question comes up again, but in a slightly different form. Do we still need to worry about giving metadata formal syntax and semantics when AI is becoming so good at natural language processing? Well, the objective of this meeting is to take a deep dive into why structuring semantic information with respect to conventional metadata structures is not only still worthwhile, but a vital thing to do. So we'll hear from Keith about the metadata element set that we've been developing in this group. We'll hear from John from the Vocabulary Services Interest Group about the role of vocabularies in metadata. We'll hear from Andrea from the Scientific Knowledge Graphs Interoperability Framework Working Group about the metadata required for effective scientific knowledge graphs. And we'll hear from Reiner from the Fair Digital Object Fabric Interest Group about the metadata required for the kernel information record in fair digital objects. And as you listen to our speakers, I want you to be drawing connections, comparing and contrasting between the points our speakers make, because after that, it's over to you. Is this a case of use it or lose it? What efficiencies can we achieve for creating and sharing formal metadata? How can we use it most effectively? How can we ensure that the benefits far outweigh the costs? If you go to the next slide, please. But before I hand over to our speakers, I just want to pay tribute, however inadequately and briefly, to Rebecca and Keith, who have been co-chairs of this interest group from the very beginning. Over the past 10 years, they have championed the role of metadata in the RDA's many activities and been the voices of common sense in countless meetings. It's down to them that this group has maintained its direction and impetus, but they'll be stepping down after this plenary. So I'm taking this opportunity to give a personal and public thank you to them for all they've done for this group and for the working groups under the Metadata Interest Group umbrella. I would say that I don't know what we'll do without them, but that's not entirely true. They're far too organized for that. So even though it's an end of an era, the moment has been prepared for. So at the end of this meeting, the last bit of business will be to welcome some new co-chairs to this group. Who will it be? There'll be no spoilers from me. Instead, I'd like to hand over now to Keith and his talk on the metadata element set.
Okay, thanks very much, Alex, for the fulsome tribute. It was very kind of you. Certainly, Rebecca and I have been trying to be the conscience of RDA with regard to formal metadata all these years. And we formed a strong collaborative way of working together with you, of course. Okay, my job is to talk about the metadata elements. Next slide, please, Rebecca. So why do we have the concept of a metadata element set? Well, the point is simply this. There are many, many metadata standards, formal and informal, in the world. And as everyone recognizes, and a key point of RDA, we need to interoperate. So when you have different metadata schemas describing digital assets, then in order to interoperate those digital assets, you first need to interoperate the metadata in order to be able to understand the correspondences in the digital assets that sit behind or beneath the metadata. So first of all, there's matching, which element in one schema matches in another schema. And this is not always, indeed rarely, a one-to-one correspondence. And it's not just attribute equivalence, because of course we have to worry about the syntax and semantics of the metadata elements involved. And in case of syntax, we have to worry about things like referential and functional integrity. And in the case of semantics, we need vocabularies commonly stored in ontologies, so you have relationships between the terms. And this is especially important in a multilingual situation. And we also need, in the semantics, context. Just consider the term bond. It has a meaning in chemistry. It has a meaning in economics. It has a meaning in sociology. And it has a meaning in entertainment, the well-known James Bond. So in order to understand what this literal, this group of characters mean, you need this deeper understanding from the semantics. Then we have to do the mapping, which is the conversion function between the metadata elements in two related schemas. And then, of course, we need software to actually do the conversion. Now, this is all a lot of effort. So, word of warning, beware the combinatorial explosion. If you relate every metadata standard to every other, we have more or less n squared mappings and converters, a huge amount of work to do. If we relate every metadata standard to one superset rich metadata standard, then we only have n mappings, and that can become tractable. So in an attempt to produce a superset rich metadata standard appropriate for use within RDA, we started work with members of the MIG on a metadata element set. Next slide, please, Rebecca. So here's the set. It has unique ID, location, i.e. location of the digital asset, description, which is free text, keywords, which are from a defined vocabulary, temporal coordinates, that is the period of time over which this is relevant, spatial coordinates, the area of space, not necessarily geospace, of course, it can be astronomical space, or it can be space within a molecule in the case of our friends working in deep chemistry. It has the originator, which is likely to be an organization or person. It has the project. It has facility and equipment, facility being something big like CERN in Geneva, the big nuclear physics center, and equipment, that's the particular experiment on the particular accelerator being used to collect the data in the case of CERN. And of course, it can be an array of sensors in environmental science. Something called quality, which is very difficult to define. Availability, which includes things like license and persistence, i.e. is the digital asset still there or not. Provenance, which we all know about, is a difficult and interesting area. The citations, because it's very important that we get the citations right, not least to give formal accreditation to the originators of the digital asset. Related publications, whether they're white, i.e. peer-reviewed, or gray. And finally, related software. So this is the element set that we proposed, and there's been a lot of discussion about it. Next one, please, Rebecca. So the point I want to make very strongly is these are elements, not single-valued attributes. Most of those elements have an internal structure, and they use terms that require declared semantics. Also, it's not exhaustive. Of course, you need many more entities and attributes or elements to describe a particular domain of research. But it is thought that if we wish to interoperate between, for example, geoscience and sociology, then this element set would help. And the use case behind that is if Vesuvius erupts, which has geoscience information background, then we need the sociological information, i.e. the social science information, in order to deal with the necessary evacuation, health protection, and everything else that would be necessary in the area of the Bay of Naples. So it's a list that is recommended as a way or a conversion target from any metadata schema in order to provide basic interoperation. Of course, one can go much further, but this is meant to be the base set, and then you can modify it with additional profiles in the same way as you have application profiles related to, for example, the DCAT standard. So the idea is the metadata element set would assist in permitting discovery, particularly from a different domain to the one in which the researcher normally operates, to support contextualization, which allows you to assess the relevance and the value of the digital assets described by the metadata, and finally to facilitate action, i.e. machine actionability, which is to do with interoperation, including query and integration. Next one, please, Rebecca. So I'd like to acknowledge that a huge number of people have done a great work on this, both at RDA events when we've run kind of do it now sessions in having discussions about the elements, and also in between RDA events. There's been superb discussion and some very interesting things came out of that. On the metadata interest group page, there's the list of elements, and each element has its own URL. pointing to information and discussion about that element from the RDA community. So my job today is to ask you, please get involved. We need to improve the element documentation, finalize the element set, so we can all begin to utilize it for interoperation. And that's the URL to find the metadata interest group, and there you'll find the element set. Thank you very much. Next slide.
Okay.
Thank you for this chance to speak with you all today in the Metadata Interest Group. My name is John Grabio, and I'm speaking on behalf of the Vocabulary and Semantic Services Interest Group, or VSIG. And we are presenting our considerations, if you like, about how the Metadata Interest Group and the VSIG can work together in technical and social ways toward our common goals. So on behalf of the co-chairs, this is my take. The vision, a bit about VSIG to start with. VSIG's vision is that semantic web technologies can be the basis of knowledge and expertise exchange really from and across any domains, and that these technologies are a good way to go forward for scientific exchange of information. The VSIG was re-envisioned in 2015 when it was the Vocabulary Special Interest Group, and has a somewhat broader remit with the addition of semantic services to the vocabulary services. It's had regular plenary sessions since plenary 14. The attendance has been good, not quite as good as you all have here. And it's spun off quite a number of working groups and activities as well. But the ongoing engagement between the sessions is relatively light in this group. We focus on collaborations with a lot of other working groups and interest groups, including with you all in these meetings and on projects of community interest. Some of the groups that have emerged from or been supported by our interest group include iAdopt, which you'll hear a lot about during these sessions, and the task groups for minimum metadata and terms and concept recommendations, as well as a number of birds of a feather sessions. So why are we here today talking to you? Significantly, because Rebecca and Julian Snyder have talked to each other and decided it would be a good thing. And as I hope you'll see, it seems clear that this is the right moment. I think we have a shared understanding of community need at this point between the two interest groups. We want to describe things, digital things, physical things, conceptual things. For all these kinds of things, we need names that have a strong meaning. And we know our everyday language that we use to talk about things isn't good enough. Alex's presentation and Keith's also speak very much to this. And so I know the Metadata Interest Group feels the same way because your presentations and homepage say so. And I took the liberty of marking up this slide, which I considered perfect as it stood. But I want to add the idea that these examples show the ideal case, but the real world is a lot messier. If everything is done right, you can machine parse this data set contains Neanderthals, but everything won't be done right. And the results might be interoperable if everything is done right. If we make our terms machine actionable, as in the third example here, then we can fix a lot of issues before they ever get encoded in the metadata at all, which is the ideal time to fix them. So from the Metadata Interest Group homepage, there is significant text that goes to the fact that we're in a stage now where we need more complex metadata about data sets, about all these other things. And to do that, we will need syntax and terms that require declared semantics, that require us to say what we're talking about. And the formal syntax and the declared semantics are really essential in order to make the metadata interoperable. So why do we talk about semantics so much? There are a bunch of superpowers I think of that a unified semantic system can provide. For starters, with the right identifiers for our terms, then we can precisely and persistently refer to a particular concept. Across the whole universe of concepts, we're talking about a particular thing. The de facto standard by the W3C, one of them is called RDF, allows descriptions and labels to be offered in very specific ways and cleanly supports internationalization. So this is a really good way to describe our concepts. RDF and the other W3C semantic standards provide a consistent standard model which strongly supports interoperable solutions. And it also supports computational logic in those cases where these standards or these definitions are being made with respect to each other and represent really models of the system they are describing. So this supports a powerful level of computer inferencing and computer action. If we put all of these things together, what you have is what I call human-friendly computability. Yes, the computer can work with these elements and can achieve good things with them, but the people can also see what's going on and what things mean. So if we're going to make this work between the metadata and the vocabularies, we're going to have to connect the metadata standards, an example of which is the DCAT model, and the controlled vocabularies represented here by a particular vocabulary from BioPortal. And the way that we can do this is with identifiers. These identifiers, as specified by the W3C's semantic community, are called IRIs, Internationalized Resource Identifiers, also known as URIs or URLs, depending on how old you are. These IRIs are the standard connectors that make the metadata and the vocabularies work together and allow the semantics to be specified. Now, this group, the metadata interest group, already understands many of the use cases very well about specifying metadata, and also understands that the many existing practices that you find out there don't really solve the use cases very thoroughly. Even strong metadata models, and I cited a couple examples here, DataCite, schema.org, are often surprisingly weak about semantics, maybe having just locally defined or even undefined terms that they're calling for. So we're really looking for something more precise and more computable in order to make data and other descriptions truly interoperable. From the standpoint of someone filling out the metadata, it's not enough to make the results interoperable. You have to make it easy to provide the results. And semantics helps here too by letting the user supply answers from controlled terms rather than insisting that they type a lot of words that maybe are defined in some text and maybe not. So with that, you can achieve a lot of these more detailed goals in your processes throughout your systems. I'm just going to give two quick examples of how this works in the real world. Many of you are familiar with the linked open data cloud, this large cloud of vocabularies that refer to each other in significant ways. This is something you can look up and find the current view of anytime. What you may not know is that the clump of pink vocabularies in the lower right, down there, are all life science vocabularies. And in those life science vocabularies, now shown on the left, all the gold ones came from a single repository. The reason that that worked was that that repository had normalized all the vocabularies to follow the same semantic standards. In many cases, they were following them already, but in some cases they were not. And by the time they were in BioPortal, people had to modify them so that they were. And this allowed us to put a whole lot of information into this very large graph of information on the web about terminologies. With BioPortal providing these resources, and now BioPortal also provides many other non-life science semantic artifacts, you can build other tools on top of it. And again, this is one example. BioPortal is one repository example. Cedar is a metadata forms example. There are other examples already in existence that can be built to allow users to design their metadata templates. So you're encoding the metadata specifications in a computable way and incorporating proper semantic practices along the way about what those metadata specifications refer to. And then the encoded specifications can generate the forms that help users or even computers fill out the controlled vocabulary terms. Now you're producing rich semantic metadata with the tools, and it becomes possible for everything to behave appropriately. So these practices work in the real world. They're working in the real world. And VSIG wants to work with the metadata interest group and other RDA groups and external groups to advance good practices in all the metadata and vocabulary-focused applications that we know are out there. This requires a lot of good practices in many different facets, from the models and representations to the repositories and the sharing approaches in the communities. These are just some examples of that. So this is my closing let's all get together and hug slide. And you can see the relationships on it that we're trying to build up and create. I invite you to join us in our session, the VSIG session, tomorrow, 9 a.m. In Mozart Hall 2 and 3. I have no idea which way to point for that, but someone will help me, I'm sure. And if you are looking for that, you can search for Koskela as one of the speakers who will be at that session. Thank you very much for your time. Look forward to talking to you more.
Hi.
Questions? Not yet. Okay, we'll save them for a discussion. Okay, next up is Andrea, talking about scientific knowledge graphs. Let me know when to advance slides.
Yeah, sure. Please next. So I am Andrea Manocho. I'm joining remotely. I won't be in RDA this year, and yeah, I'm a researcher in for the Italian Research Council. And I've been running this working group on scientific knowledge graphs for like about 1 year now. And yeah, we didn't manage to organize a session for this edition, but thank you, Keith, for inviting us and having a quick recap here. So as we know, science is a complex socio-technical system, and we know there's this evolving network of persons, organizations that publish in collaboration literature and also non-literature elements, such as software and data. And all this endeavor takes part in having people sticking together in terms of projects and research communities. And please next. And tracking all these evolution. Can you move to next slide, please? Yeah, and tracking all this evolution is non-trivial, also because the open science practice is urging researchers to trace all these daily endeavor, and this entails the deposition of research entities that go beyond PDFs. So data, software, but not only these, not only research products, but also ideas and concepts and methods and protocols that have been followed during the day in, day out their work, and also all the relationships that connect all these research entities and actors. They're possibly using multiple registries that we created all over these years, and this ends up in a plethora of different metadata depositions in a plethora of services and platforms that are scattered across the web. Please next. So as I was saying, like all these traces are scattered, and there are multiple stakeholders that are trying to reconstruct all these traces and have a global view of the scientific track record. And this is surprisingly a crowded space. So it's always a surprise to see a new kid joining the pack in this market segment, I would say, and you can find both non-for-profit and corporate industries competing for traction in the very same business segment. And please next. By the way, I'm involved in the efforts. No, sorry, the one with honors only. Yeah, I'm involved in the operation of the open air graph. So let's say that I also carry with me the experience that I grew all over these years, incorporating with the technical team within this project, and now it's a servicing on its own. So the best shot we have in such a fragmented ecosystem, if we want to to reconstruct the truth, as even though the truth with capital T can't be achieved, but if we want to try to asymptotically approximate the truth of all the work that has been carried out over the years in the research, the best shot is to establish point-to-point collaborations between these different stakeholders, different platforms and services around. And this, as Keith was saying in the introduction, entails to n-square complexity, which is really non-optimal. And in this dream of trying to do better than that, we established our work. So please next. So the idea is to remove those errors, which were by no means, let's say, thorough. They were not like exhaustive. They were just as an example of some collaborations that are out there. The idea would be to replace those point-to-point collaborations or data consumptions into something that's more like a cloud, federated, where different initiatives, different services can agree upon a common language that can be effectively used as a mean to understand each other. Pretty much we do with English during our meetings, international meetings. And so please next. So like I think it was 2020, yeah, we published a small position paper who set things moving. And in this paper, we drew a first classification framework across 7 dimensions for open science graph. Back then, we were sticking to this terminology, but then we saw that European calls and even abroad, like the jargon that was more that had been adopted or elected as the reference one was the one about scholarly scholarly or scientific knowledge graphs. So at some point we switched to that as well. And in this first paper, we were trying to have a first classification framework for different OSGs or open science graphs or scholarly knowledge graphs. And across 7 different axes, 7 different dimensions, mostly like what were the entities modeled and the application served, and the locally added value in terms of, for example, data application or subject classification or any metadata enrichment that could have been introduced down the line, and methods for exporting and provisioning the data, as well as the data sources that were ingested and integrated to produce the resource itself. And then last but not least, fairness and openness. Please, next. And our history in RDA, so we were incubated in the interest group on open science graphs for fair data, and we started as task forces our work towards the interoperability framework that now has been transitioned into a working group on its own, which I am co-leading with Jason Portnoy from OpenAlex, Silvio Peroni from Open Citations, and Sahar Badati from the INFEA Institute. And so the good thing about the working group is that we try to have a representative or a spokesperson from major actors out there, such as DataCite, OpenAlex, as from OpenAir and Open Citation. So we try to have big players onboarded from the beginning, trying to, that in the hope that whatever we come up with can benefit of some traction right from the start. And the whole gist of it, please, next. Yeah, that's the slide I was hoping it would show up. Is that basically if you have an SKGs out there and you pick one at random, then you want to give the opportunity to people to opt in to this interoperability layer where they can map onto this common language and provide them specifications on how to interoperate on a technical level. For example, providing access via APIs as opposed to data files or dumps where all the data is shipped and exposed to other people to be used. And then the last bit would be we're connecting back to the first to this position paper that I mentioned earlier. It was about the catalog. It would be about the catalog, meaning it would be nice to have an extensive resource that lists different SKGs that are available openly or not, and to provide manifestos with some metadata about the SKG itself, providing some high-level description on what has been offered and how. And please, next. So the work has been carried out in 4 compartments. Let's say at the beginning we were calling them task forces. The first one was iterating on the information model. So we started from a selection of initiatives of different SKGs. We started reviewing the models of them all and trying to check which were the entities, research entities, for example, paper, data, software, contributions, meaning authors' affiliations contributing to certain papers. So we were trying to track all the entities that were represented most of the times. And then we moved to the second activity, which was about trying to understand, to to pin which were the attributes that were more commonly expressed. And all these was to have, like this very pragmatic approach to trying to end up on a minimum core set of metadata that could be effectively represent our knowledge domain, and not to lose so to have to be expressive as possible, but at the same time not to catch all the different shades and flavors that might be represented in peculiar aspects of every SKG at hand. But like trying to blur into those details for the benefit of being expressive and common in a shared level across all the initiatives. The third action was about understanding and actually it's ongoing, we are trying to discuss on the access protocols. So like from a technical perspective, how do you want to suggest SKGs, maintainers, and operators on how to achieve data exchange across them. And then the fourth one is about the profiles, which is registry about SKG manifestos, where each one describes what is being onboarded, how the data has been derived and improved locally. Please, next. So yeah, if you want to see more about our ongoing work, you can go at this web page that's at the displayed at the bottom. This is the data model that we released in summer, and which we isolated basically certain research entities that were of interest, and they were mostly shared by all of them, being research product that could be either literature or data or software or more topics. So subject relating to subject classification, mostly persons, organizations, grants. At the beginning, we were calling it project, but then kids. That was a cross mistake. And then we have sources, data sources, and venues. And here the distinction is a bit tricky, but we are trying to capture the difference between where the publication was intended to be published, for example, a conference or a journal, and data source instead tries to capture where the metadata is got from. There could be conferences whose proceedings are published on Zenodo. Then, in that case, the venue would be that conference, while the data source providing the metadata would be Zenodo. In other cases, Zenodo or archive have been selected by the researchers publishing the material as the primary venue of publication, because, for example, it's a white paper. And in that case, the venue is Zenodo itself, and the data source is the same. Please, next. And yeah, so this is a screenshot from the documentation page, which, we are having fortnightly meetings. So on a weekly basis, we have a couple of changes. This is the latest revision. For example, now we introduced languages for titles and abstracts, because at the beginning was just a bare bone list of streams. But then someone pointed out that it might be valuable to provide some means for multilinguality, which we were not supporting at the beginning. So we discussed that, and we decided to make the model a bit more complex to this extent, but to give this opportunity to whomever has this kind of information on board. There are versions, so if you click on the bottom left corner, you can switch between releases. So this is the latest one. If you go, can you hear me? I hope so. I don't know why. The microphone is I don't think it changed. But anyway, let's try. I reached the end of my presentation, so.
Hearing you.
Yeah, I hope you heard enough, or most for most of the part of it. Okay.
No, most of it was really good. It's just getting quiet.
Yeah. Okay. Just in the last bit.
Okay.
Okay. Yeah. That's pretty much from my side. I didn't want to go on a more practical, like trying to provide you with practical examples on mappings that we're doing. Just I want to conclude saying that we started a crosswalking activity between OpenAir and this model here, and by I hope next year within spring, DataSite and OpenCitation will do the same. DataSite has to do that because it's part of the Faircode for Reuse project, this activity. So there will be more crosswalks towards this interoperability framework from our members. And yeah, so that's the end of my reporting. Hope that's clear.
Okay, next up is Rainer and Fair Digital Objects.
Moin. We're talking, so what I'm presenting now is a quintessence or just a summary of the research result and the development result of many people and many consortia and groups and so on. And one of them is the RDA interest group on Fair Digital Object, the Fabric. We are here in the metadata IG, aren't we? So we'll talk about metadata. And if I'm talking about metadata, can I point with that? Is this a pointer? The green one? No. The other green. Ah! I'm talking about metadata that is describing these fair digital objects. So we agree on that metadata has a purpose. And this metadata I'm talking about is for the description of these fair digital objects. But first about what are fair digital objects? We are here in research and working with research data. And we know that researchers are very creative. They're creating data formats. They're creating manifold of container formats, RO crates, HDF5, +++. And we know that there won't be an agreement, that there won't be one format. So what we need is a kind of an overall representation of all these different formats that can be treated as the same or similar. And then we go back and down to the data itself and we can interpret the data. And this overall representation, this is the idea of the concept of the fair digital objects. It's a representation of a digital asset or digital bit stream or whatever it is. It contains of data. It has a reference. It is referenced and identified by a persistent ID. This is important. And it has properties described by metadata. And this is the metadata I'm talking about. Here you see a kind of a picture of the fair digital object. I like it very much because it's so wrong. It's not a sun. It's not an onion. It's not a container. It is a kind of a concept that points to information that you need for the interpretation of the fair digital object. It is a general concept, which means it's technology agnostic. It doesn't depend whether it's RDF behind or XML or JSON. So it's a concept. It is agnostic of the carrier technology, and thus the idea is long-lasting and can be sustainable. Since it's technology agnostic, also we have the interoperability and with the consensus kind of a harmonization. So it can serve as a bridge between various data repositories, disciplines, and so on. Furthermore, if you are looking at research data, that is important. We have more legacy research data out there than new research data. So we need the seamless inclusion of legacy data. And here, the idea is that data has a type. If you know the type, for example, the data is an image, you know what you can do with the image. You can visualize it, you can rotate it, and so on. So then we can also connect operations to a certain type. And now the question is, how do I implement then it? And of course, the answer is metadata. Here we have such a kind of an idea of an implementation, which is derived from RDA recommendations of the PID information types, the data type registry, PID kernel information. And the idea is simply that we have, for example, in the handle PID, we have the PID itself, it's here, and we have a PID information record. And the PID information record has entries, key values. So first of all, I need to define how these key value pairs and the sequence of key value pairs looks like. We need a schema for that, which is the PID profile. There can be various PID profiles, and many can exist. We have a type, the data type, image, for example, and the location URL where the real data is, maybe in a legacy repository or somewhere, but it must be somehow persistent. And this is the minimum information that I need, the minimum metadata that I need to handle these fair digital objects. This is the information I need. Of course, and we know we need more information. We are scientists, and we need to know, if I have an image, what does the image describe? What does it point to? So what does it describe? It can be a probe. How was it imaged by tomography, for example? Which kind of parameters? And then information in the scientific process has been derived of it. So, for example, it's a certain kind of a defect in the probe or whatever it is. This is a different kind of metadata. And this is the metadata which is really interesting for us as scientists, as researchers, but it's not in here. Here, we are just pointing to the information. So we had these recommendations of RDA, what to put and how to shape this, but it's not sufficient. And for that, we did a certain kind of an extension of that, which is the Helmholtz kernel information profile. And Helmholtz is not the researcher Helmholtz. He died more than 100 years ago, so he didn't work with fair digital objects. Helmholtz is called because it has been developed in the Helmholtz Association in Germany. This is the association of the large-scale research centers in Germany. And we took here the RDA draft kernel information profile, which is the RDA recommendation, and we extended that by other information. So, for example, here you see an example. Of course, we need a certain kind of a license for reusability. We need to point to this information. Then some security parts, checksums and signature. To which topic does it belong? And what is even more important, since we are in the metadata IG here, it points also to the metadata, which is interesting for scientists. So here in has metadata, it can point to metadata fair digital objects that can either describe the probe which has been imaged, the image format, the machine which has created the image, or whatever you like. So here, many metadata objects can be referred. It's a list. And what does it mean? So you have these manifolds, and each of these metadata objects can be also represented as a fair digital object in itself. Which for example, we can have a fair digital object describing a data set. so referring to a data set, and others which are referring to metadata sets. And here all the this information we need for our scientific processes in there. And I think, if I understood right, this also corresponds a bit with that what Keith was talking about, the metadata element sets. So, in principle, you can use it such a kind of a profile, and for your task, you can extend it. So, for example, if we have also a fair digital object that contains metadata or refers to metadata object, it's also interesting to see it is metadata for which data object or other metadata objects. So this one is extendable, and this describes as a metadata set my fair digital object as a kind of organizational or administrative metadata. That's it.
I'm going to do things just a little bit out of order so that we can have a longer discussion. I wanted to introduce, we have two new co-chairs. It's 5 in the morning for Stephen, so I don't think he's on right now. But Stephen Richard has agreed to become a co-chair. He's in the US and he has a very extensive background in metadata, especially within the earth sciences. And at the next plenary, have him introduce himself. Milan is online. And yes, I wish I could do justice to his last name.
Milan Oystercheck.
People online can't really speak.
Last name.
Oh, yes, please. Could you say your last name?
Oystercheck.
Anyway, I wanted to thank him, and I'll work on learning how to pronounce that. And he's been involved in many of the metadata interest group meetings. So I also thank him for stepping forward to be a co-chair. And he's also a co-chair of the CODATA GOS Data Interoperability Working Group, which is, and among other things. What's really nice is there are a lot of organizations out there. So Steve Richard has a lot of connections within ESIP, the Earth Science Information Partners Program, that's mainly in the US, but it also has a group in Australia. And CODATA has many working groups that are very similar to RDA. So it's nice to have co-chairs that are knowledgeable about what's happening in other organizations. And I really appreciate Stephen and Milan for stepping forward. So now that I've done that, we can go back to the discussion. And I'll start out. Do we have any questions from online? And if you're online, I'd encourage you to ask questions. But in the room, do we have any questions? And Wim, you can introduce yourself.
Yeah, Wim Hugo of Dance in the Netherlands. So the interesting question for me, and maybe Rainer and others, Keith and so on, have some thoughts about this, but we have a hierarchy of metadata descriptions in persistent identifier stacks, as I call them. Some of those stacks are short. You can go directly to an authority and register a persistent identifier. Some of them are very long. They have an authority, and then they have multi-party administrators, and then they have providers and managers and so on. And the question arises, where is the authoritative copy of that metadata, and where does the responsibility lie to maintain it? Because in some cases, you need all of that information depending on their end use, but mostly the people who interact with the resource being identified is at the far end of this chain. they work with the repositories and maybe the managers such as DataSite or Crossref and so on. So I think there is a need to somehow get a consensus about how to define the authoritative bits of this metadata chain in such a way that it's machine and human understandable.
So Keith, do you want to take the first part? Then Reiner can speak up.
Yeah, thanks for that. Thanks for the question, Wim. I agree with
Are
you.
you there, Keith?
Yeah, I'm here. Can you hear me?
Yes.
Yeah. Thanks for the question, Wim. I think it's very important thing that you raise. There is a huge danger if you build a stack, particularly of semantic constructs, on top of the base metadata, which is usually close to the individual digital asset, that this can become so distant that it becomes impossible for the end user to get what they really want. So I think we need to do everything we can to collapse this structure, to make it as flat as possible, and to allow the idea that, first of all, the syntactic metadata is close to the digital asset, ideally the same repository, and secondly, the semantic interpretation of that is in two kinds. First of all, the initial semantic interpretation stored as an ontology ideally associated with the repository. And secondly, other semantic interpretations that can be in the linked open web. The reason why I'm stressing it's good to have the syntactic and initial semantic metadata close to the digital asset is that that means they're close to the management of the digital asset and the organization that created it and is responsible for it. Moreover, if it's close together, it's much easier to ensure that any logic processing done on it is safe. In other words, it becomes a closed world related to that environment of that repository, and you can have multiple open world interpretations, but they are liable to be computationally unsafe in certain ways. Therefore, it's safer to make sure you have a closed world around the digital asset and its immediately associated metadata. I hope that answers that part of your question.
Yeah, I hope so that it didn't. It does also answers the second part of the question. To be honest, I'm not an expert in this direction. If I look at access rights and so on, of course we have these different objects relating and pointing to other objects which are in repositories. There we have the governance. There we have the access managed. But as a global thing, no idea. To be honest.
Any other questions? Yes, please go ahead.
My name is Barbara Magana, and I have a question. Although I'm involved in the Fair Digital Object Forum, I am still wonder how what you presented, Reiner, relates to the Fair Digital Object Framework of Luis Boninos and others. So there is a relation. I see this. But is it another dialect of the same thing? Where does it differentiate? Can it work together? What is the plan how to converge here? Because it's another specification.
Yes, it's a different kind of a specification. And currently the fine specifications are flowing and so on. And some of the implementations are, of course, technology dependent. Must be, because if you need to implement something, you depend on a certain kind of a technology. The idea in behind of the concept is the same. There in the Fair Digital Object Framework, the technologies, the underlying technologies are based on the idea of linked data. If you look at that, what I have presented here, it's basically the same, but with a different kind of an implementation. So I don't see here a big problem in the interoperability of the concept, but in the implementation, this has, of course, interoperability problems. These are a couple of things what we are currently doing in this direction. On one hand, the Fair Digital Object Forum that concentrates currently on the specification. And I hope that there will be a specification that will provide this kind of interoperability. It's not finalized in detail yet. In RDA, we have with the IG, Fair Digital Object Fabric, we have here an IG just to enforce or foster the communication and the exchange of the implementers. They talk to each other. And we hope there that we have a second kind of convergence process. But it's slow.
Thank you.
I took your seat. I'm sorry.
No, that's perfect. That's fine. Yes, please.
Is this on? Oh,
Yes.
thank you. So I had a question regarding the...
Could you introduce yourself?
Oh, sorry. My name is Volmar. I am part of some of the interest groups here, primarily the Life Science Data Infrastructures interest group, and also the VSSSIG, following those activities. So I had a question about the metadata element set, and I was wondering, is there currently a way of representing the information represented by the content of the data being described in some way that would make it kind of discoverable on the semantic level? So, I mean, there was a free text description field, but I didn't really see one of the fields or elements describing the quality or quantity or the thing being represented in the data set itself. And I think that would be useful for data integration scenarios and search, for example.
So Alex or Keith, do you want to address that?
Alex, do you want to have a go? Or if not, I will.
Well, you start and I'll chip in if there's anything.
Okay. So hi, Walmar. Good to see you here. The answer is, if you look at the element set, you'll see it does have an element called quality, and there's been very interesting discussions about how to define quality. And as you say, it also has a free text description, and it also has keywords. The keywords it's expected will come from a declared vocabulary, ideally an ontology, and that will therefore give you the additional search capability and the additional search precision that I think you may be looking for. Certainly the idea was that the element set would be a neutral syntax, a neutral structure with the added semantics, and there has been no definition of the way in which the element set should be implemented. The actual idea is you should be able to implement it using RDF or XML or anything you like, basically. It's meant to be technology independent. Alex.
Just to, well, amplify that point is that one of the, as Keith was saying on his slide, one of the things that we're hoping the metadata element set will be useful for is to be that kind of Rosetta Stone for translating between multiple different metadata formats. So one of the jobs it's trying to achieve is being able to identify where certain bits of information occur in different standards, and some information about how they're being encoded, so that we can get a kind of initial process for being able to convert between them without having to, you know, create individual one-to-one, point-to-point mappings between individual metadata schemes. So yeah, and as we were saying, the quality is one of the things that we're focusing on in the metadata element set.
My fault. If I could add something to that, I think your question and the one before it go directly to the hardest problem of interoperability, which is that next step that Alex and Keith were just describing of, okay, I have my definition. Now I'm going to implement it. Same to your comments as well. And I know when I was working on the CEDAR project, full disclosure, Mark Musin is the lead of the CEDAR project and is no longer my boss, so I can say anything I want now about it. So these are now totally my thoughts as opposed to anything I said before. No, but working on the CEDAR project, which is about creating a tool that lets you specify the implementation of a metadata set. It's really hard. You can take a really well-defined specification like DataSite and DCAT and try to say, okay, now I'm going to do this for this application. And anyone who's done it knows it immediately gets really hard to do that in an interoperable way. And I don't know that there's going to be a really clean answer to your question in any quick turnaround. Yes, this is the answer. Everybody will sign up to it. Sorry. Yeah. It's where we're going, right? It's where we're trying to go. Yes.
Is this on? Yeah. Oh, all right. So I think that addresses some aspect of this. I mean, the quality thing. I meant the quality of some judgment. I mean, how the information was produced, not the quality of how it was produced, so to speak. So what is in is represented in the information, and CEDAR is one way of solving that on the technical level. But then you also have the more elusive, like what information is represented, and you might want to have a structured way of doing that and not just the free text one. So maybe have description and structured description or something like that. And then, I mean, maybe the keywords is that, but it just didn't click for me directly. So thanks.
Can I say something about it? So I'm convinced that probably I have another point of view, but I'm convinced that it is important to have common metadata. Some parts should be completely interoperable, but some part can be very community specific. R1.3 is about community specific standards. And I think we don't want any more free text. We really want specifications that are fair, but they can be built with CEDAR and other tools. And they don't need to be that interoperable because you also want to understand more about the specificity of the data. That's my point of view. I see that's not always the same for others, but we are from GoFair Foundation, we do the M4Ms, and we are working towards community-specific metadata.
Go ahead.
Okay. All right. Hi. Anita de Waard, Elsevier. Thank you for the session. And I have maybe a simplistic question. Within the science publishing community, some of us are trying to move from XML to a format called CP/LD, CP:/LD. You can look it up. It's a proposed NISO standard, which essentially would propose that scientific papers would look like HTML5 plus JSON-LD. And for me, one of the strengths of that format would be to enable a lot of the types of interoperations that have been discussed here. And we've actually joined the group that Andrea was giving the talk about on Science Knowledge Graph. Here's my question. I drank the Kool-Aid. I'm completely on board, but I would love to have a couple of examples where things are possible between scientists, between clinicians and scientists, between different domains, between funders and librarians or something, because of this system of interconnected metadata that weren't possible before. So any exemplars that would help me to try to get the publishing community along, my own company along, try to convince other publishers, proprietary or or whoever that this is a good way to go, because it will require investment. It will require a new way of thinking, and that'll only work if we have sort of examples that are clear to explain. So just an open invitation to anyone, speakers or in the room, of any suggestions of good examples. Thanks.
I nominate Barbara and Mark to stand up and say something. I mean, when you say that, let me ask one question to clarify. When you said convincing publishers to implement that was just generally metadata and semantics together, or something more specific?
Sorry, and I don't mean to say that CPLD is the be-all and end-all of formats, but for me specifically, to see if we could move in a direction where we have linked data be part of the scientific record, sort of from the get-go. That's my personal thing that I would love to be able to help explain why that would be a good idea. Thanks.
Yeah, Mark can.
Well, since John put me on the spot,
yes,
I don't have the good compelling example that Anita wants.
Could you introduce yourself?
Pardon?
Introduce yourself.
Oh, I'm sorry. I'm Mark Musin from Stanford University. I'm here because John said I had to talk. I'm not aware of a dramatic, compelling example of what Anita is looking for, but an experiment that shows part of that will be on display tomorrow. And I wish I could tell you what time the session is. I think it's at 2:00. DataCite has been leading a project called Fair Workflows, which is looking at the challenge of taking standardized metadata created through CEDAR and being able to use those metadata to annotate data sets in Dryad, to acquire DOIs from DataCite, to basically communicate with everybody in the ecosystem of publishing and data management what's happening with particular experimental data using a common metadata model. It's early in its work, but I think it gives you a flavor for the kind of thing that I believe Anita is talking about, and might provide a way of at least seeing where the world might go next. And obviously, I'm part of that group. We're certainly looking for ideas as to how to extend these ideas.
Any comment from the remote speakers?
This is Keith. I'd suggest taking a look at what OpenAir are doing in Europe. They have done a vast amount of work on providing a science knowledge graph, which connects together in a fully connected graph structure all these different things, including collecting different PIDs, harvesting, obviously, from repositories and so on, connecting it to data sets, linking with DataCite formats, and on and on and on. And I don't know if Andrea's still here, but he's a member of that team, so he might be able to say more about it than I can. Andrea.
Yeah. No, thanks for so I mean, just I want to reconnect to the point that Anita made, and yeah, because she pointed that out in one of the previous meeting we had, and I'm with that, because there are several there have been actually several proposals on how to make scholarly content, scholarly metadata more interoperable and connected, referring, for example, to nano publications coming from the semantic web world, or even I don't know if anyone is familiar with the OKERG. Is a big it's a big ERC consolidator, I think, project from Southern Hour, still semantic web community, where basically what they did, the beauty of the concept is that, you know, like you can rather than writing a PDF and bury inside the document all these knowledge which is valuable, you could mark up actually certain bits and expose the knowledge rather than, you know, hiding it in plain sight, so that it can be machine operable somehow. And the OKRG project is trying to do that. If you land on the web page, you can search for publications, and then, for example, for algorithmic complexity, you could find different algorithms. You could match them along certain kind of features, and these could, for example, have benefits for systematic state-of-the-art review. But then, yes, like there is this problem, like all these are, and CPLD is something that I need to check still, since the moment I need to point me to that. But all these are valuable examples. And but then I think there is a critical mass problem, you know, like, and it's when you have competing proposals that and that are kind of disruptive. You also want people to have a sizable amount of people to stick together and push for that, because otherwise it would be pretty much confined in this like in this early stage prototypal phase, without having chance really to flourish. And then, for like connecting to what Keith was mentioning, like, yeah, in OpenAir we are aggregating data from thousands of different sources. Like everything started from open access archives. And then the content acquisition policies were step by step broadened and made more compliant to open science. So now basically we have we don't restrict anymore to open access content only, but we also can get metadata about papers which are behind paywall. We do have, and we try to re-establish all the links between different entities in the research, different research products beyond literature. So we have data, software, and other research products. For example, gray literature, presentations, deliverables, technical reports, and so on and so forth. And now, from this year, we are trying to explore how these can change or can benefit the research assessment reform. I know that in RDA there's going to be a bag of feather on these, so I'll try to in the next days to be up to date on that. But yeah, I mean, if you're interested in the research about assessment and research evaluation, please do search for this group. And within GraspOS, which is this project that it's on research assessment, we are trying to understand how open science and scholarly knowledge graphs, OpenAir, and all the others can be used to provide a more rich asset and evidence to understand research and researcher evaluation of their work. And yeah, so I don't know, Keith, is there anything else? You were referring to something particular?
Then time's going to be up. So
yeah,
one last question.
Then, oh, okay.
Hi, so I have more of a comment than a question. Yes, I'm one of those. Vida Plankite.
Could you introduce
yourself? Vida Plankite. I do user experience RSpace, so I'm not actually a researcher at all. So I've been just jumping into this. And one thing we did as a project recently is taking one specific PID, so IGSNs for physical samples, and then implement it into our inventory management system using the DataSite API. So we had a few use cases of universities that were like, we're doing field research. We need to, have PIDs. And so now researchers can just quickly mint identifiers, fill in some basic metadata, and it's just kind of straightforward. It's limited, but it's something. But even with that, there were so many
things that kind of went wrong, like even just understanding like what a landing page is or like who should host it. It's like, oh, it's the university, right? And I was like, well, no, it's DataSite, right? And then DataSite was like, no, it's actually you. And I was like, us? We're supposed to host the land? And then it's like going through the design process of that. So I wonder, I mean, in this case, it was a grant, so we were lucky to be able to do this, but what would you say are ways for us to have more of these, like, okay, the schema is good enough. The technical schema is also good enough. Let's just try something and see what the actual issues are with the practical implementation.
How to decide that? How to decide that the schema is good enough?
Or even how to have situations where you can actually promote and have institutions or integrators just try a small portion of a project and see where it goes wrong or goes right.
Yeah, I think your answer was in the question. You do it quickly, you consolidate the work and get people to try it, you iterate on it. That would be my answer.
Okay, and this is an advertisement that we were asked to show for a PidFest. It's coming in June 2024. It'll be included in the slide set. Reiner, last comment.
Yeah, maybe not the last comment, but before you close the session, Rebecca, you and Keith, you worked here for more than 10 years in RDA. I cannot speak for RDA. I can just speak as an RDA member and how I've seen you and your contributions. So you shaped RDA like it is nowadays. RDA US, you were very active in RDA US. You were the director. You shaped the governance. You created with your groups extremely important results. This is really the most important part for me. And you also shaped here our discussion culture. And I would like to say just thank you. Thank you, Keith. Thank you, Rebecca.
And thank you to Keith. Did you want to say anything before we close?
No, there's nothing really to say. We just did our job.
I agree. Thank you for coming. I will have the slides made available on the website fairly soon, so that if you weren't here or if you were remotely, you can have a copy of the slides.